Hey everybody, it's time with the Brothers WISP at WISPAPALOOZA 2024. I'm here at the LibreQoS booth with Robert, and you guys are here in the flesh.
We're here in person, and we're excited to share with people what we're developing.
Okay, yeah, and so LibreQoS, walk me through this. This is a really cool presentation.
Thank you. So essentially, what we built is I run a small ISP in West Texas in southern New Mexico, and about 4 years ago, we were struggling with the quality of experience. We compete against mostly coax incumbents and fiber optics. So we wanted a quality of experience engine that could kind of handle the unique cases of our network. So what you see here on the screen is the main dashboard of the free and open source LibreQoS product. This is a modular dashboard, so all these are widgets. You can completely customize the order, the size of each widget. This is just a particular setup that I have at the moment, but you can, for example, edit this and load different layouts. So I'll try a more recent layout that I prefer slightly more, but you can save these layouts, share them with friends, things like that.
Okay.
And in terms of what we're seeing, so the first is just obviously bandwidth or throughput at the moment.
Yeah, upload and download all the way over here, and that's a cool speedometer.
Yeah, and then to the right of that, we have the proportion of shaped and unshaped traffic. So on my network, thankfully, we have all the IPs identified, so there's only a tiny, tiny sliver of unshaped traffic, which is probably, maybe ICMP coming into routers that are rejecting it, stuff like that. And then we have the packets per second, just giving an idea of the total load. And then tracked flows. So a recent development we have is that we actually do track flows now, in addition to round trip time and retransmissions.
Okay.
In addition, you can see about 3 to 5 minute graph. What this also does, though, is it ties into the LTS product. So LTS is, in addition to this free and open source dashboard that you see here, that does mostly the shaping of traffic, we also have a product that offers the long-term storage of statistics. It can be locally hosted on premises, or it can be hosted in the cloud, completely up to the operator. But it's an optional service.
Okay.
And then if we go down here, you can see the SAN key. So the SAN key is revealing essentially how is our network doing color-coded. So the green is good, red is bad.
Yeah.
We can see the top 3 tower sites that I have on my network. Everything here is just kind of censored for customer privacy, but you get the idea. The top one is one of our main distribution sites that has about 220 clients, but you can see the RTT is solid. Mm-hmm. On the right-hand side is the same information, but just kind of laid out differently. So if you don't want it visually illustrated, it's also
I'm seeing like there's red bars and then there's red circles and such. So is that explaining different information as as it goes?
Yes. So for example, on that's the top 10 downloaders on the network, which is a good metric of just how are people doing that are actually maxing things out. So you'll notice here this person has red on the inside of that main square. What that indicates is that their utilization of their link bandwidth is about 100%.
Okay.
But you also notice that on the exterior ring, that's all green, indicating that the round trip time is solid. So this customer is hitting their ceiling sandwiching at maybe 100 megabits per second, but they're perfectly happy because the latency is under control.
Okay.
The band size indicates also the utilization.
Yeah.
So
bigger is bigger.
Bigger is bigger, but just gives kind of an idea of the proportion of traffic, kind of where it's going among those top 10 users.
Okay.
And then if they're having a pleasant experience, you're going to see green on the outside. You'll see blips where there's someone getting kind of red on the outside, and we can click in on that and see what's going on for the client.
Yeah, and then down here is the worst, the people who are not having a good experience.
These are folks who are struggling. So these are the worst round trip time. In some cases, you'll actually still see a little bit of green, but it's generally folks that are maybe they have an affordable IPTV service that beacons home to a foreign country, something like that. Okay, so kind of things like that will produce weird results, and we want to click in and kind of see how they're doing. So we can do that. We can take a look at this client and just kind of see, how's their experience going right now. So we see they're not using too much data. I think this is about, like 18 megabits per second. They're on a 115 meg link. Okay. So it could be that it's kind of bursty traffic. We're seeing the throughput, retransmissions, the RTT, but we can go into the flows. So let's take a look at what they're doing. We don't do deep packet inspection, but we do look at the ASN that they're connected to. We find that to be useful information because you can deduce, if there's an issue with your peering, things like that. So we can see here that there's the majority of traffic is going over, I guess, ICMP and HTTPS to some various ASNs. Yeah. But it's just kind of a neat live view. It
looks like Apple.
Yeah, probably something. Maybe going over an Apple VPN back to something.
Or
something like that.
It could be something like that, yeah.
And you can also illustrate this on the network traffic tab, which is basically the same data, but just laid out a little bit differently. And it's all a very, very live view, so you get an immediate view of what's going on. You can also, of course, pause this if you just kind of want to see what's happening in a split second. And then this is something that's kind of neat. So if we're trying to troubleshoot, why is this person having a hard time? This kind of stands out. So this is the Q tree. So we can go all the way down. This person is on, I think, some sort of micropop really deeply nested in the network.
Okay.
And we can go all the way through all the levels of the hierarchy and see where did this problem start. So we go to the very beginning. The round trip time distribution histogram indicates, everything's pretty solid. Things aren't really being squeezed toward the far right. They're not being squeezed toward the high latency. But as we kind of navigate up here, something happened. And this is their AP. So what happened there, we can deduce, okay, their AP is having trouble. This saves you a lot of time that would normally be spent checking or cross-referencing support calls with what towers are having issues, which towers are reporting issues through SNMP. You can immediately spot this, and it saves a lot of time.
Yeah, this is all in one spot. So you have AP, POP, backhauls, everything all lined up right there. That's super beneficial. Yeah.
Yeah, and then here we have the cake shaper, which just indicates, what is the cake shaper doing for each client. So we do things a little differently than other QE solutions. Some will do it, will do traffic shaping kind of at a more aggregate level, right? So they might do things like see Netflix traffic in aggregate and say, we're going to kind of squeeze this by 50%. We don't do things like that. We don't think that's necessarily beneficial to the end user experience or to the operator's utilization of bandwidth. Instead, we give them a fair slice using an HTB from the Linux traffic control system, similar to how other QoE products do it. But what's distinct is that we use cake. So within that HTB, within that fair slice of the traffic that they're allocated, we then do the queuing. So from there, we have 4 tins. We have bulk, best effort, real-time video, and voice.
Okay.
As you can guess, real-time video is probably like Zoom calls, Teams calls, things like that. Voice traffic. But on a client that might be doing, for example, a voice call, you'll notice that although the backlog and the traffic will indicate those packets, the drops will not be on those packets. It'll be on something that is perhaps best effort or bulk traffic.
Yep. And then if we and you do that all auto-magically, I don't have to configure what is what.
Yes, and that is the beauty of it. Cake, is the result of about additional 8 to 10 years of development work on top of FQCoddle. So FQCoddle, we all know from all of the impact it's made on the industry, not just on APs and clients, but also on QE solutions. It's actually the basis of most QE solutions that we see here.
Yep.
So, Dave Todd is one of our team members, and he's one of the co-authors of FQCoddle and Cake. So he's helped us to really better integrate this. But that's the beauty of it, is you're not having to really fine-tune everything, twiddle a bunch of knobs. It just kind of does this automatically. Assuming you provided the accurate information, it does the rest.
Yeah. And what kind of information do you need?
Well, for example, I have here on the right, this is our tree overview. So I happen to use UISP. I'm a smaller shop, and we happen to use a lot of Ubiquiti equipment. So we pull in all of this using API calls to the UISP system, and it pulls information such as, the APs we have, but not just that, the entire topology. So we're doing kind of like with OSPF, we're actually looking at where the origination point is and then mapping it out that way. You can have multiple origination points. So if you want a root site for one of your shaper boxes running LibreQoS that has the perspective of one exit point of your network, you can have another exit point of your network with a different perspective of the network tree.
Okay.
So we can accommodate that. So here I have major towers on this area, and then you can see RTT is green, things are good. Most of these are APs, but some connect to micropops, which then connect to more APs and then connect to clients. So this is just a cool view to kind of see at a high level, how's the network doing in a very live way.
Awesome. So, and basically all of that information just comes from your system that you already have, UISP, that you're maintaining anyways, because you need UISP to work.
Yeah.
And so basically anyone who already has some sort of a billing and network monitoring system like UISP or like Sonar or something like that, you'd be able to pull the information in? Yes,
it's most tightly integrated right now with Splinks, which is a product that we highly recommend. The Splinks team has been working with us to better map out network topology. In addition, we of course support UISP, we support Sonar, Power Code, and we're adding additional NMSs, like we're working right now with Gaia to try to add functionality for their system. But if someone has a system that's not more formally supported, you can write an integration to produce the output files that we need. It's just 2 files. It's a CSV and a JSON file. That's all that's needed, and you can update them at whatever regularity or interval you find most useful for your network.
Okay, awesome. So, really flexible in the ways that you can ingest the data that you need and then produce really, really, beautiful network monitoring tools. Yeah. So, awesome. All right, so what would be like one of the last things you would want to express for people out there who want to take a look at LibreQoS?
Well, I would say, I come from the perspective of a small network operator, and competing against these large incumbents, I feel that this has saved our business. That is the large motivating factor of why we do this. We're not just developers. Herbert and myself both are network operators. So we see and use the product. We eat our own dog food, so to say. You can see here, this is on the long-term stats product. This is a site that should not have worked with any other QoE solution, based on kind of the rules of thumb that most might suggest. This site has a 1 gigabit backhaul. It just sandwiches against the ceiling just barely with little spikes, but the RTT is solid. The experience is solid in a way that it just can't be if you don't use hierarchical queuing. So I think the hierarchical queuing is a really cool advantage of how we do things. I think it helps small ISPs in particular, but it's scalable to over 30 gigabits per second. We have one ISP that's a fiber ISP that's pushed this to 100 gigabits per second. So reach out to us, let us know how we can help. Reach us on the Zulip chat on our website, and we'd be happy to help you launch a test bed, see if this is something useful to your network, and help you get it off the ground. Awesome.
Well, cool. Well, I appreciate you showing up here, and I hope that it's been a fun show for you. Last question: what was the coolest thing you've seen here?
I would say some of the wireless technology that we're seeing is really incredible in terms of what it's making possible for operators at different budgets. And in addition, I would particularly shout out the Wisdom team on the network RF planning and network planning side. I think their product is stunning. I think it is really, really impressive.
Really cool. All right. Well, thank you very much, Robert. Check out the links below and reach out to them and say hi, because these guys are super fun and would love to chat. So, and very knowledgeable. So thank you very much.
Pleasure to speak to you.